In this video, we are going to look at covalent bonds. And so by the end of this video, you will be able to use patterns on the periodic table to help you draw the dot diagrams and model how they meet the octet rule by forming a covalent bond. So while you're watching this video, this is the only thing you should have open, and make sure you're using headphones because I really want you to be listening to what I'm saying. Mind your time, most video lessons shouldn't take more than 10 minutes. Make sure you're taking notes. So a good rule of thumb for this video is anything that is written in red or that I write down myself, you should be writing in your notebook. Make sure you have the date, so 11/3/25, written at the top of a new page, and our topic, covalent bonds. Notes. Answer the questions that are in the end of the video and put them in your notebook. I will be checking them when I return, and pause and rewind as much as you need to. So a covalent bond is a bond formed between two or more nonmetals, so the ones that gain electrons. And the way that they do this is that they share electrons, specifically the ones that aren't paired up and that are by themselves, to be able to meet the octet rule. And so if you look at the video, the picture of the two atoms, you have A has one lone electron and B has one lone electron. So they both share them. So they both still have it. They don't get rid of it. They share like custody of it. And then they count that as part of their 8. So for A, it would be 1, 2, 3, 4, 5, 6, 7, 8. And then B, we would do 1, 2, 3, 4, 5, 6, 7, 8. So they both share the electrons that they are giving up to each other. Kind of like divorced parents with their children. So how to draw covalent bonds. And so we're going to use our checklist just like we use for ionic and covalent bonding to help us draw. And we're going to follow this checklist every time, and this is how I'm going to be grading your work to make sure that you're meeting every single step. So first is draw the dot diagrams for each element with the element with the lowest number of valence electrons in the center. So if I look on my periodic table, oxygen has 6 valence electrons, chlorine has 7. I'm going to put oxygen in the middle. And the reason for this is because the lower the number of valence electrons, the more bonds they will have to form. And so you want the one that forms the most bonds in the center. It'll help you with drawing. So I'm going to do one on each side. And then I'm going to pair up. So 5, 6. And then I'm just going to do Cl at the bottom because I know that lone electron is going to have to pair up on oxygen. So 1, 2, 3, 4. I'm going to start pairing them up away from the center. 5, 6, 7. So I just have easy access on pairing them. Then I'm going to circle all unpaired valence electrons, so all single electrons. And so oxygen has 2, and chlorine has 1. So I did that. Now I'm going to draw a line that connects the lone electrons of one element to the lone electrons of another. So one of the electrons on oxygen can pair up to the one on chlorine, and I'm actually just going to circle them. And so they both now have ownership over these 2 electrons. And so oxygen has 1, 2, 3, 4, 5, 6, 7, and chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So chlorine's good at the octet rule, but oxygen only has 7. So what I'm going to do is I'm going to add another element, but I'm not going to add another oxygen. I'm going to add another chlorine because I don't want to keep adding the element that hasn't met the octet rule because it will never meet the octet rule if you keep adding that element. So I'm going to go ahead and add another Cl. 6, 7. I'm going to go ahead and circle the unpaired electron. And then I'm going to connect the two lone electrons, the one on chlorine and the one on oxygen. So now chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So chlorine's good. And oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And so oxygen is good. And so the last step was just repeat until all electrons are paired. I know they all have a partner. So these are paired up and these are paired up. There are no electrons by themselves. So I know I have met all steps and I am good to go. So the way this would be written would be O1Cl2. So we're going to do this again, but we're going to do two of the same elements. We're going to do fluorine and fluorine. So if I look back at my checklist, the first step is to draw the dot diagrams. Since they're both the same element, there's not going to be a real center. I can just put them next to each other. But fluorine has 7 valence electrons. And so if you notice, I put the single electrons towards the center because I know I'm going to be pairing them up. It'll just help to draw them with the lone electrons towards the center. And so your second step is to circle all the lone electrons. So each fluorine has 1. Your third step is to pair them up. So I'm just going to double check that I have met the octet rule for both fluorines. 1, 2, 3, 4, 5, 6, 7, 8. So this one has met the octet rule. And then the other fluorine, 1, 2, 3, 4, 5, 6, 7, 8. So that fluorine has met the octet rule. And so what that would look like, if you were to draw it, would be this. More simplified and not as many dots. It would look like that. And this would be F2. And so then we're going to do one more together. We're going to do carbon and oxygen. So carbon has 4 valence electrons. Oxygen has 6. Because carbon has less, I'm going to put it in the center. And then I'm going to put oxygen on the outside. 1, 2, 3, 4, 5, 6. I'm then going to circle all my single electrons. 1, 2, 3, 4. And oxygen has 1, 2. So carbon can form 4 times, form bonds 4 times, and oxygen can do it twice. So then my third step is to pair up all single electrons. One from each element. So I have 1 carbon there, and then I have another single electron on both of them that I can pair up. And so because I have no more to pair up, I'm just going to double check to see which one has met the octet rule. So carbon has 1, 2, 3, 4, 5, 6. So carbon is not good. And then let me check oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is good to go. So to help carbon meet the octet rule, I'm going to have to add another element. I don't want to add carbon again because adding the same thing that doesn't meet it is not going to help you out. I want to add another dot diagram for the element that has, because I know it can meet it again. So I'm going to do another oxygen with 6 valence electrons. 4, 5, 6. I'm going to circle the lone electron so I know how many I need to pair up. And then I'm going to draw a connecting line or circle of the lone electrons on each element. So 1 from carbon and 1 from oxygen. And then I have nothing else paired, but I do still want to make sure that it met the octet rule. So I'm going to count again. I'm going to use bright green this time. So carbon has 1, 2, 3, 4, 5, 6, 7, 8. Carbon is good. And then oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is good. And so what this looks like would be like that. And we would write it with the lowest number of valence electrons first. So C would be written first. And I have one of those, and then O would be written next. And I have two of those written, so it'd be C1O2 or CO2, carbon dioxide. And so looking at F2 and CO2, you can see that F is connected once to the other F, but between a C and an O is connected twice. And so there are different numbers of bonds depending on how many times they're connected between a pair of elements. So when there is one connection, meaning they each are sharing one electron, so 2 in the bond total, that would be a single bond. A double bond is when each one is sharing 2 with another element. So between an oxygen and an oxygen, they are each giving each other one electron to share, and then a triple bond would be 6. So it's sharing 3 electrons per nitrogen with the other nitrogen. And I do want to point out that having what we saw earlier, OCl and Cl, this is not a double bond because there are not 2 bonds connecting one oxygen and one chlorine. These are both, these are both single bonds because between each oxygen and chlorine, there is one bond or 2 electrons being shared, one from each. In order for it to be a double bond, it has to be connected between the 2 elements twice. So between this one oxygen and chlorine, you would have to have 2 connections, 2 bonds for it to be a double bond. So this would be single. So what I want you to do in your notebook is to try drawing these practice questions. So the first one is phosphorus and fluorine. The second one is sulfur and bromine. And then the third one is bromine and fluorine. So follow the steps in the video for the checklist, and that should help you. And then when you're done, I want you to copy these 2 pictures in your notebook and tell me, is it a single, double, or triple bond in the portions that are circled for number 4 and number 5? So again, for questions 1, 2, and 3, you're practicing drawing these pairs, P and F, S and BR, and BR and F. And then for 4 and 5, tell me what type of bond you have between the circled pair of elements. I will be checking these when I return on Wednesday.